So I still feel like I gave you enough work that we can just pick through multiple choice problems out of there today. Okay, so I am going to talk for a minute. I added one thing to Schoology that I assigned in Delta Math, which you should still have access to. They have flashcards that are supposed to be like really, really good. Like it's just problem after problem after problem after problem. I can't see all the problems, but in my Calc Facebook group, you know, where all my cool friends are, they like people love them. And so that is also a really good spot. Then there's the in Schoology. Another super smart person from the Facebook group made like 175 multiple choice questions. And Mr. Deggets, who's the calc teacher at South, typed them all up and made them all into individual units in Schoology. So you have multiple choice questions in Schoology, you have Delta Math flashcards, and then I gave you that link to all the free response. And then there's this mixed bag of review that somebody made last year, I think. And so I gave you lots and lots of stuff so that you could really do as much as you wanted to do or felt that you needed to do. I would do any of that as long as you do some practice with multiple choice and some practice with free response. If you want to focus on specific topics, I would go to the Schoology multiple choice and find those. And then I would take, like I gave you the 2014 practice test, I would like do the free response from that, like do a whole set of free response. And then you can also do a whole set of 2016, which I have solutions for. So if you're doing free response, I would do them as like a whole chunk. So you can find the, you know, some are really easy and some are really hard, and that's okay. All right, so let's go through this multiple choice. I need to connect to Zoom from my iPad. Cannot sign in. Please check network connection. Oh, super. Nope, I'm signed in. I didn't even do anything. Is the title of this like you're in my 7th hour or something? Do you know?
I don't think so.
Like that link I put, I think is my link to my 7th hour class. Doesn't matter. I just, well, let's see. Let's join 7th hour and see if I end up in this room. I did not end up in this room. Well, what are we in? Oh, there I am. Okay, so we're in my help session. I'm confused. Anyway. All right, so if I share this. All right, you looking at my multiple choice? Okay. So I know a couple of you did this and hopefully you have questions for me. If you guys want to throw in the chat or unmute and say out loud, and I'm just going to do problems. If you're opening this yourself, this is the 2014 practice exam. So in Schoology, There's a folder for 2014 practice exam. So those of you that did it, throw out a couple ones you would want me to do. Can we do 5? I kind of forgot how to do those. You betcha. Okay. So figure above shows the graph of f, which is true. The limit as x approaches 2 from the, that's got a little negative up there. That means from the left. Okay, the limit as x approaches 2 from the left. So we're headed here, right? Is equal to f of 2. That's what that question's saying. So what is the limit as x approaches 2 from the left? We're approaching -1, right? What is f of 2? That's the point right here. -1. So this one's true. All right, number 2 says the limit as x approaches 6 from the left is equal to the limit as x approaches 6 from the right. From the left, we're going to -1. From the right, we're going to -1. Both of those are -1, so that is true. And so the limit as x approaches 6, without saying left or right, which means both, of f of x is also -1. But what is f of 6? That's that point, which is -3. So this one is not true. Okay, so remember limit is just if you follow the path and you're pointing, that's limit. What are we going to? It's the y value that we're heading towards as we approach that x value. 7. Oh yeah, we're not very good at these. Limit as x approaches infinity. That's usually a horizontal asymptote. Means what's happening as we go out to the right. Except this one doesn't have, we're not very good. We don't know what this is because it's e to the 3x. So our horizontal asymptote rules don't work. So the only thing we can do is just think if x were like 100, what would we be approaching? So we would have 100 cubed over e to the 300. And we're probably not approaching a specific value. We're probably either approaching 0 or approaching an infinite. So e to the 300 is going to be huge, right? 2 to the 300 is going to be bigger than 10 to the third or 100 to the third. This is biggest. This is huge. And if the bottom number keeps getting bigger and bigger and bigger and bigger, if the bottom number gets huge, we're approaching 0. Is that the answer? I don't have answers in front of me. I get kind of nervous working on the fly here. I'll look it up. Yay, I got it right. Okay, so really you're just looking at like 1 over n approaches 0 as n approaches infinity. As n gets really, really big, we'll get like 1 over a million, 1 over a trillion, which means we're approaching 0. We did not do very much work with those. All right, 8. So this is u sub, but they're giving you the u. Like that was always the hardest part of u substitution, right? You couldn't figure out what u you were supposed to use. They're doing this one for you. So u is sine of 2x, which means du is cosine of 2x times 2 dx, right? Chain rule, and need the times 2. And this is where we have to change our bounds. If we're switching to u, we need to change our bounds. So the integral from pi over 6 to pi over 2 in the x world is going to be what in the u world? Well, we know that u equals sine of 2x. So if x is pi over 2, then u equals sine of 2 times pi over 2, or pi. Pi is over here. That's -1, 0, so sine is 0. So when x is pi over 2, u is 0. When x is pi over 6, u is sine of 2 times pi over 6, right? Which is sine of pi over 3. Which is up here. That's short, long. So 1/2 √3 over 2. So sine is √3 over 2. Oh, did I write those backwards? I did, didn't I? So √3 over 2 goes with pi over 6 to 0. And so I know it's one of those two. And then I need to substitute in. So sine of 2x, this is u, right? And then cosine of 2x dx. This will be 1/2 du is cosine of 2x dx. So in place of this, I put 1/2 du. So this is now √3 over 2 to 0 of u to the 5th times 1/2 times du. That's a really good, very straightforward u substitution problem. All right. Any questions? Okay. All right, number 10. I'm just going through the list that people have been sending me. What makes f continuous? Or what value of b makes f continuous? So basically those are two different pieces, right? I got function, I got half of it over here and half of it over here. Actually, no, that's not true. I've got a full function, but I'm not sure what's happening at 2, right? I've got this top function for when x is not equal to 2, and then this right here. What does that mean? That means there's a hole at 2, and I need that second part of the piecewise to fill the hole. Okay, so if you want to go about it backwards, you can just plug in these values. That's a really good way to like use your multiple choice. So let's do it that way first. If b is -3, and I'm going to factor this as x minus 2, x minus 5 over -3, x minus 2. And then my other function will be basically the point to -3, right? If b is -3. So my hole is at 2. You see that? My hole is at 2. And so when x equals 2, right here, I'm going to have -3 over -3. I'm going to have 1. And here, when x equals 2, I'm going to have -3. So that doesn't make them in the same spot. So one option would be to plug in like that. That's not the right way to do it. Okay, the right way would be to factor this top. So x minus 2, x minus 5 over b times x minus 2. Those cancel. So it's x minus 5 over b, right? So I need, this is the y value when x is not equal to 2. This is the y value when x does equal 2. You with me? That's just what the piecewise means. So I need to know what b makes them in the same spot. So I need to know when x equals 2, which is my unsure point, that's 2 minus 5 over b equals b. I need those y values to be in the same spot. And so -3 equals b squared, which is not possible. So there is no such value of b. Okay, are you guys good? Is this what you want? Let me just keep going. Okay, all right, 12. F of x is 9 to the x. If 4 subintervals of equal length are used, what is the value of a right Riemann sum approximation for 0 to 2? So I would make the table. That's how we like to make them, right? I would make a table of x and y. 1, 2, 3, and I need 4 points so that I have 1, or do I need 5 points? I need 5 points, so I have 4 intervals. I need to go 0 to 2. So I'm going to go 1, 1/2, and 1 1/2. This is one of those like really extension problems, like we've never done one this way. So if you missed this one, I would be totally not surprised. Like this is one most of my students would miss because this is like a real extension of what we've done. We've never done one just like this. Okay, but let's take it and convert it into a table because then we have no problem with Riemann sums. Okay, so when x is 0, y is 1. When x is 1/2, that's the square root of 9, which is 3. When x is 1, y is 9. When x is 3/2, 9 to the 3/2, that's the square root of 3 cubed, that's 27. And 9 squared is 81. So that's probably what I would have done, is create the table so that you can do the right Riemann sum. So if we do the right Riemann sum, we need the difference here. So these are all 1/2 times the right side of the rectangle. So this one's going to be 1/2 times 81, 1/2 times 27, 1/2 times 9, 1/2 times 3, and we don't use the left height. So this is going to be half of, well, it's going to be 3 halves, 9 halves, 27 halves, and 81 halves. So those are 90. That's 30. That's 120 over 2. 60. Dang, I got that one right too. Look at me go. If you think to make the table, it turns out to be pretty easy, right? If you try to like make it overcomplicated than that's the hard part. So, you know, probably you'll never see one like this again. But if you do, if you want to do a Riemann sum, you need values, you need a table. All right, 17. Okay, so we know our rules about e to a power, right? The derivative of e to the power is itself times the exponent, right? It's chain rule. A is a constant. It's a number, right? It's not a variable. This is not product rule because A is just, this is no different than having 2e to the negative 2x. If that's your function, then the derivative of that is 2e to the negative 2x times the derivative of the exponent, which is negative 2, which is negative 4e to the negative 2x. You could even do it that way and then figure out which one of those answers match it if a happened to be 2, which would be negative a squared, which should be this one. Okay, with a, using a, you'd say that the derivative of this constant stays out front, rewrite e to the negative x times negative a, so negative a squared e to the negative ax. So that should be e. All right, back it up to 16. So you don't know what this graph looks like because we've never done that, which means you're probably going to get this one wrong unless you make it. I mean, it's really easy to graph if you can think about it. So if we just plot some points to see what this graph looks like, if there's time, save this one, come back to it later. If you have time at the end of the multiple choice, spend some time seeing if you can graph it because the limit's really easy if you're looking at a graph. And so we're going to have to approach 3, so let's pick values around 3. So let's pick 0, 1, 2, 3, 4, 5, and see what's happening. So when x is 0, you have 3 over negative 3, so negative 1. When x is 1, you have the absolute value of 1 minus 3 over 1 minus 3, which is the absolute value of negative 2 over 2, negative 2, which is negative 1. And you should start to go, huh, what about other values there? Let's try 2. 2 minus 3, absolute value over 2 minus 3. You're going to have always positive on top and the matching number on the bottom, negative 1. When we get to 3, we're undefined. But now when we go bigger than 3, like 4, we get 4 minus 3 over 4 minus 3. That's going to be positive 1. And then we get 5 minus 3 over 5 minus 3. That's going to be positive 1. And then we get 6 minus 3 over 6 minus 3. That's going to be positive 1. So this graph looks like at 3 here, when we're to the left of 3, when we're to the left of 3, we always get a value of negative 1. When we're to the right of 3, we always get a value of positive 1. And if we want to approach 3 from the left, we're talking about this right here. Or look, if we just look here, we're approaching 3 from the left. We're hitting negative 1 until we get 3, which is undefined. So it's negative 1. You don't know that graph naturally? Again, skip it, put a circle around it, come back to it at the end of the multiple choice if you have time, and see if you can figure out a graph for it and think of it graphically. Okay, 21. Okay, our first look on a limit is direct substitution, right? So we're going to say the limit of x approaches 2 of this is natural log of 5 minus natural log of 5 over 2 minus 2.
Did you say you're going to do 21?
Yep.
This is 20.
Yep. Well, we'll just go ahead and do this one. You're right. I was going to do 21. Okay, so that doesn't work. And so we did remember we did all kinds of factoring and rationalizing and blah, 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 blah. And then like right before the last day of school, I was like, oh yeah, there's this fast, easy way called L'Hopital's rule. So you just take the derivative of the top and then do the derivative of the bottom and then plug that in. So this is the limit as x approaches 2 of the derivative of natural log of x over 3 is 1 over, or x plus 3 is 1 over x plus 3 times the derivative of the inside, which is 1, minus the natural log of 5 is a constant, so the derivative of that is 0, over 1 minus 0. So this is the limit as x approaches 2 of just 1 over x plus 3, direct substitution, 1/5. Which is not the problem you guys asked for, but a little bonus. 21. Oh. I'm going to say this is a related rates problem that I haven't done. So let's see how I do. Ready? All right, functions w, x, and y are differentiable with respect to time. Reading that gave me my clue, are related by, those are the words I saw that I was like, oh, related rates. Okay. That function, if x is decreasing at a constant rate of 1 unit per minute, that means dx dt is -1. Okay. Y is increasing at a constant rate of 4 units per minute. So dy dt is +4. At what rate is w changing? So find dw dt when x equals 6 and y equals 20. Okay, so all I did was take all the words and put it into calculus notation. Now, hopefully it's just easy enough that I just take the derivative and plug everything in. Related rates, we really tend to overcomplicate those, but at related rates, is change it all to rates, which means take the derivative, plug in, and hopefully find your missing piece. So if we have w equals x squared y, I need to take the derivative of that. So the derivative of w is 1 dw dt equals, this is going to be a product rule. X squared times y is the product rule. So if I take the derivative of x squared, that's 2x dx dt times y. That's derivative of the first, keep the second, plus the first, x squared, times the derivative of the second, that's 1 dy dt. And hopefully I just have everything I need and can just plug in. And so I need dw dt, that's what I'm trying to find. 2 times, I got x is 6, I got dx dt is -1, and I got y is 4. Plus x squared, that's 36, dy dt is 4. This actually ended up being a really easy, very straightforward related rates problem. So this is -48 plus, what, 36 times 2 is 72, so 144. So -144, or -48 plus 144 is 9, uh-oh. Something's wrong. Anybody know what I did wrong?
Y needs to equal 20, not 4.
Thank you. That is correct. Y needs to equal 20. So that's 12 times 20, which is -240 plus 144, which is -96. So I know we hated related rates, but this was a pretty easy one. Okay, so if you happen to run across an easy one, we'd like to get those right. If it tends to be overly complicated, don't worry about it. Something else will be easy somewhere. All right, 28, and then I don't have any more suggestions after that. If anyone wants to add to the list. 28, slope fields. If I had to pick a topic in this class that I'm worst at, this is it. So I kind of want to cheat and look at the answer, but I'm not going to. Okay. All right, so we need to figure out which of those little slopes match these equations. So this is, you're going to get my fresh thinking process. If I've ever done this problem, I don't remember doing it. So my fresh thinking is I'm going to see right here that at y equals 1, dy dx is 0. Because this is 1, 2, 3, right? So that's my first look. That's the first thing I saw. When y equals 1, the slope is 0, no matter what x is. So I'm going to go eliminate some of these, maybe. So if y is 1, here I'd have x minus x, so that'll be 0. And on this one, I'm going to have, when y is 1, I'm going to have 2x, right? So that's not going to be 0. And here, when y equals 1, I'm only going to have 0 if x is 1, so that's not it. And then when y equals 1, this will give me 0, this will give me 0. So I eliminated 2 things with that thinking. Okay, so I'm going to go back up and look, and I like to take like a quadrant at a time. So I'm going to try to look at a quadrant that's all going the same direction, which is this one right here. I'm going to take this quadrant. And so when X is positive and Y is negative, I don't know why I wrote equals is, dy dx is always negative. That's what I can say from that quadrant. So if X is positive and anywhere in here, when X is positive, Y is negative, then dy dx is negative. Okay. So again, this may or may not work. I don't even know if this is the right thinking. So X is positive. So this is going to be a positive times a negative minus a positive, right? That's going to give me a negative minus a positive, which is always going to be negative, right? This will always be negative. So I can't eliminate that. All right, then here, if Y is negative, this will be negative. And X will be positive, so this will always be negative. And here, if Y is negative, then this will be negative, and that didn't help me at all. Right? Let's try the same thing, but over here. Here, when X is negative and Y is negative, then dy dx is positive, right? That's what those are telling me. So A, this will be negative times a negative minus a negative. That's going to be a positive plus a number, which will always be positive. Dang it, we're not getting anywhere. All right, let's do D. This will be, if Y is negative, this is negative. If X is negative, this is positive. So this will always be negative. So I got to cross another one off. Woohoo! And then if Y is negative, this is negative, still negative. Oh, so I get to cross this one off. Woohoo! And honestly, those are not my strength. I'm not the fastest at those. There may be other people that are faster, that are quicker, that see that better, that find a different route. That's fine. Those aren't my best, but I still got the right answer if you take the time to do it. Okay. I was looking to see if there's any other route there. Okay, that's all the problems you've put into chats. What else? Oh, that's it for those. 28. We're supposed to be 30. There wasn't 30. I don't know why. What else? Do you know what to do here? Derivative of an integral, that's fundamental theorem of calculus, right? So you plug this in here and chain rule. So it'll be 1 over 1 plus square root of x squared times the chain rule, which is 1/2 x to the negative 1/2. And then you got to make that match. So 1 over 1 plus x times 1 over 2 root x. That looks like A. What else? I feel like we didn't do a whole lot of these with the piecewise, but it's really easy. F prime is -1. That means we're using this one because that's where F is -1. So F prime of X for there is -2X. And so F prime of -1 is positive, -2 times -1, so +2. Nope, that's not right. My bad. See, that's why I look at answers. What do you think? Any ideas? Nothing? Usually we take for granted that most problems say the function is differentiable. Or else I'm not finding other examples. The function is differentiable. Like we often just kind of look over that, right? So if I think about what this looks like graphically, this is 3x plus 5, so up 5. It looks like that, except it stops at -1. So it looks like that. Right, and then the left side is -x squared plus 3, so that's up 3. Oh. And so it looks like this, except only from here over. So why can't I do F prime of -1? It's not differentiable there. It's not continuous there. Even if those met at a point, there'd be a sharp turn. And so that function is not differentiable at x equals -1. Tricked me. That's easy. That's easy. They love those. You want to do that one? I feel like we're not super good at these all the time. Here's a differential equation. The point 0, 2 is a point on the original. So when you've got these steps, I would ignore the steps, do it yourself, and then see where theirs doesn't match yours, or at least closely. So separate the variables. That's going to be dy over here, dx over here. So I'm going to leave x, and I'm going to make this 1 over y, and then I'm going to check and see that they have that, which they do. And then the integral of 1 over y, that's natural log y equals 1/2 x squared plus c, which they do. And then I'm going to e both sides. So I get y equals e to the 1/2 x squared plus c. That is not what they have. But the c is weird, right? So is that just a constant? No, remember we'd write it like this, c e to the 1/2 x squared. because e to the 1/2 x squared times e to the c, and this is a constant. And so we could just call that another different big C and move it out front. So this is their error. Just a little quotient rule. Those are the ones you definitely need to get right. Something like that would be like, for sure, get that right. The rest of these questions that you guys didn't ask about are all the same concept. Here's a big chain rule. So the outermost part is the cube, so that's 3 sine squared of x squared. So you did that part of the chain. Now the sine, and so the derivative of that is cosine, leaving the inside. So you did that. And then the inside, so 2x. So that's 6x sine squared, that one. So really the ones you didn't ask about are all basic, take the derivative, take the integral. Those are the ones you guys got to get those right. Okay, here's just an integral. Okay, so that's going to be 1 over a number that's natural log, right? So this is natural log of 2x plus 1. Reverse chain rule, right? You need the reverse chain rule there from 1 to 2, and you'll just plug in. This is a basic derivative, plug in 2. This is the slope of the tangent line, that's derivative. This is an integral, plug in. And then the other ones you're not asking about, which is good, is all the straightforward. Where's the minimum? Make an F prime number line. That one's probably tricky. We can come back to that in a second. Take the derivative. Particle motion at, what is the position? That's going backwards 1. Where is it decreasing or increasing? What's the one I wanted to look at again? It was a graph. The maximum value on a closed interval. This is an absolute max that they're asking about here. Somebody asked in the chat, do you think I need you to get an AP review book? I think everything I put in Schoology under 4th quarter is plenty of stuff, more than enough stuff to practice. I would probably use that stuff instead of an AP review book. If you want an AP review book, then I would do that instead of the Schoology stuff. But you can't do all of it. You just can't do all the practice that's out there. There's so much stuff. Okay, so maximum occurs on the F prime number line. So we've got a 0 here at 0. We've got a 0 here at 3. And we got a 0 here between 5 and 6. And it's positive, negative, positive. So the maximum could occur at 3. So it could occur at 0, 3, or 6. That's where the maximum is. F of 0 is 1. What am I missing? Well, from there, we're going to increase, right? At 0, we're going to increase, and then we're going to decrease. And then we're going to increase. So we need 6, and 3 is not even an option. What am I missing? It's 4? What did I do wrong?
Don't you need the y value? Like the y value of 6 on the graph of F.
Yeah, but how am I getting them? That's actually not the answer.
I just like counted, basically. Because like it starts at 1,
0, 1.
and then it goes up 2, and then goes up 1, doesn't go up at all, goes down 1, goes down 2, and then goes up 2. So I just like counted that all together, which is not like calculus at all, but
And got 4?
yeah.
Because the rates are increasing.
Yeah.
Oh, we never did one like that either. All right, it's 9:55. You guys got class at 10. Encourage your friends to come next time. We had 9. We lost somebody along the way. That's okay. And so if you look at Schoology, everything you need is in there. I did put one of the Mondays, I'm actually out of town. And so we only have 3 Mondays to meet. But luckily I'm here the one right before, so that's good. So tons of stuff in Schoology for you guys to practice on. Bring me questions for our meeting times. Clearly you guys have plenty of time to fill with questions. I can do problems. These can go whatever you guys want them to do. So, okay, is that helpful? Okay, have a nice week. Bye.
Thank you, Ms. Malone.
You bet.
Thank you, Ms. Bullering.
You
I
betcha.
got all I need to for the day, and I absorbed a good bit at the end.
Perfect. There you go. All right. Have a good day.
You too. Bye.
Bye.